let's dive into something that, it sounds a bit heavy at first, quadratic equations. But stick with me here, because these are not just some boring math problems you'd find in a textbook. No way. They're actually like secret codes for solving some really cool real-world puzzles. So to kick things off, I want to connect a few things you'd probably never think belong together. Yeah, I know, it sounds like the beginning of a bad joke, right? A prayer hall, some marbles, and a toy factory walk into a bar. But seriously, the answer that ties them all together? That's what this is all about. You'll see how each one of these seemingly random things points us toward one single, really elegant mathematical concept. Okay, so our story starts with a real-life challenge. There's this charity trust, and they want to build a brand new prayer hall. But here's the thing. They're not just throwing up 4 walls. They have some very specific rules for how it needs to be built. And our job, it's to take their wish list and translate it into a solid mathematical plan. So here's what they've laid out for us. Rule number 1, the total carpet area inside has to be exactly 300 square meters. Not 299, not 301, 300 on the dot. Rule number 2, and this is the real brain teaser, is about the shape. The length of the hall has to be 1 meter more than twice its breadth. Kind of specific, right? So how in the world do we figure out the actual length and breadth with just that information? Well, my friends, that's where a little bit of algebra becomes our superpower. Okay, this is where the magic really happens. We're going to translate all those words into the clean language of math. We have no idea what the breadth is, right? So let's just give it a name. Let's call it x. Now, if the breadth is x, what did the rules say about the length? It's 1 meter times more than twice the breadth. So that's 2 times x plus 1, or 2x plus 1. Simple. And we all know from grade school that area is just length times breadth. So look at that. We've got all the pieces we need to build an equation. So let's just plug everything in. We take our length, which is 2x plus 1, and we multiply it by our breadth, which is just x. And what does that all have to equal? The total area they want, 300. Boom! We've got an equation. We are getting so close to cracking this. All right, let's tidy this up a bit. If we multiply that x through the parentheses, we get 2x squared plus x, and that all equals 300. Now, for reasons we'll get into in a sec, let's get everything on one side of the equal sign. We just subtract 300 from both sides. And what are we left with? 2x squared plus x minus 300 equals 0. This right here, this is the key. This is the thing that's going to unlock the entire puzzle. And this special kind of equation, it has a name. And it's the absolute hero of our story today. So think about what we just did. We took a real-world problem, a building plan, and turned it into this neat little equation. Now let's pull back the curtain and figure out what we're actually looking at. What's the official name for this thing? What makes it quadratic? Here's the official definition. A quadratic equation is basically any equation that you can shuffle around to look like this. ax squared plus bx plus c equals 0. The a, b, and c are just numbers. They can be anything. But the real star of the show is that x squared term. That's what makes it quadratic. And that a, the number in front of the x squared, is super important. It can't be 0. I mean, think about it. If a was 0, the x squared term would just disappear, and poof, it's not a quadratic anymore. This format, ax squared plus bx plus c equals 0, has a special name. It's called the standard form. You should think of it like a template or a blueprint for a house. Whenever you see a messy-looking equation, your first job is to clean it up and see if you can make it fit this blueprint. If it fits, you know for sure you've got a quadratic on your hands. Okay, time for a pop quiz. This is where it gets fun, because sometimes these equations are tricky. They like to wear disguises. You can't always just glance at one and know if it's quadratic. You gotta be a bit of a math detective. So let's put on our Sherlock Holmes hats and investigate a couple of suspects. All right, here's our first case. Take a look. What's your first impression? You see those little 3s up there, the cubed terms, right? So your brain probably screams, nope, that's not quadratic, that's a cubic equation. But is it? Let's not jump to conclusions. Let's do the work and see what's really going on under the hood. So first things first, let's expand that left side. X plus 2 cubed. Okay, now, wait a minute. Look at this. This is the cool part. We've got an x cubed term on the left side, and we've got one on the right side. And you know what that means? They completely cancel each other out. They're gone. So once we move everything else over to one side to get it into that standard form, just look at what we end up with. Would you look at that? It's a perfect match for our ax squared plus bx plus c equals 0 blueprint.
The equation was a quadratic equation hiding in a cubic's clothing. This is a perfect example of why you can't judge an equation by its cover. You always have to simplify first.
Okay, case number 2. Now this one looks like a slam dunk. It's got to be quadratic, right? I mean, you've got an x times an x on the left and 2 x terms getting multiplied on the right. This seems like an open and shut case. But, a good detective is always thorough. Let's check our work. Whoa, check that out. It's the complete opposite of the last one. When we multiply everything out, we get an x squared term on the left and another x squared term on the right. So what happens? They cancel out, and all we're left with is a simple, plain old linear equation, where the highest power of x is just 1. Isn't that wild? The one that looked cubic was actually quadratic, and the one that looked totally quadratic wasn't? Okay, so now that we're pros at spotting these things, even when they're in disguise, let's go back to that riddle I asked at the beginning. The prayer hall was just our starting point. Turns out, these equations are hiding absolutely everywhere.
Think about a puzzle. Say you've got 2 friends, John and Giovanni, and they're playing with marbles. You're given some weird clues about how many they have. Or what about a totally different world, a small toy factory trying to figure out its daily costs? One's a game, one's a business. They seem completely unrelated, right? But you can model both situations perfectly using a quadratic equation.
And if you do the math, these are the equations you end up with. Do they look familiar? Of course they do. They're both in that perfect standard form we talked about. This is so cool. From building a hall, to playing games, to running a business, quadratics are this fundamental tool that helps us make sense of the world. Now, you might think all this x squared stuff is pretty modern, something cooked up in a lab recently. But that couldn't be further from the truth. People have been wrestling with these exact same kinds of problems for literally thousands of years. This isn't new math at all. It's ancient wisdom. I mean, we're talking about the ancient Babylonians. They were solving problems that were basically quadratics. The famous Greek mathematician Euclid, he came up with a way to solve them using geometry. And a huge amount of the algebra we use today was pioneered by incredible mathematicians in India, like Brahmagupta and Sridharacharya, and in the Arab world by the great Al-Khwarizmi. When we solve these, we're really walking in the footsteps of giants. And this quote really just nails it. Everything we've done today has been about step 1, figuring out what a quadratic equation is and how to spot it in the wild. But that's just the beginning. The next big step, of course, is learning how to actually solve them, finding the value of x that makes the whole thing work. We call those solutions the roots, and that's a whole other adventure. So I want to leave you with this idea. You now have a new pair of glasses. You can see the hidden mathematical structure in the world around you. The perfect arc of a basketball shot, the curve of a satellite dish, even the way a company prices its products. So keep your eyes open. Now that you know what to look for, you're going to start seeing quadratics absolutely everywhere. Thanks so much for tuning in.